Zero Trust, enhancing app access using DNS. And for this, I would like to invite on stage Mr. Ranjit Dhalwani, who is Regional Sales Director at EfficientIP. Giving a brief introduction for Ranjit, he carries over 25 plus years of experience in the telecom and network security business. He has been closely associated with the telecom industry right from the dial-up to the ongoing 5G revolution. And to join him, we will have Mr. Chirag Nagda, who is Customer Solution Architect Team Lead at India from EfficientIP again. Chirag carries over 15 plus years of experience in IT industry, working along with customer base of enterprise, telecom, ISP, government, BFSI on providing network infra and network security solutions. With this, please welcome both of them with a huge round of applause.
Good afternoon. It's nice to be among you this afternoon. And to introduce myself, we are from EfficientIP. EfficientIP is a French company, and we are going to be talking about one aspect of Zero Trust. Now, we are going to be looking at the DNS perspective from the Zero Trust architecture. It's a very elaborate topic, of course, and we will just cover one small part of it. But it's a very important part because if you see any application or service that any user wants to access, the first transaction is a DNS transaction, right? And if that itself is compromised, or if there's some issue in it, the complete process of application access would have a challenge, right? So we are going to cover this dimension of Zero Trust from a DNS security perspective, right? So before we talk about the specific topic, we'll talk about briefly about the company that we represent. Yeah, sorry for that. So Nanda, yeah, right. EfficientIP is a French company, and we are in the market since the last 2 decades. We started off as a IPAM company, IP address management, and we developed this complete suite of DDI or DNS, DHCP, IPAM, and matured along the lines from a security perspective. So we have a wide experience in this particular domain, and the solution that we offer is an integrated DDI or DNS, DHCP, and an IPAM solution. This kind of gives you perspective of what the network infra is up to in terms of visibility, in terms of automation and control, and more importantly, security from all these protocols that we mentioned. Right? We are quite a global company. We have been in multiple countries. We are growing. We have been in the Indian markets in the last 7+ years. We have customer base in a lot of segments, market verticals, including government, telcos, BFSI, or large enterprises. That's something that we have been doing since the last 7 years. We have an ecosystem of partners and distributors through whom we have been offering these solutions to the market. So it's a 2-tier model that we engage with the customer with, and we have a good amount of skills in the country with a good amount of partners and customers being trained on it. Yeah. If we look at the profile of the solution that we have, now as I mentioned before, getting into the actual Zero Trust solution, we thought we'll just give you a brief on the product offering that EfficientIP has. These are 4 pillars that we have. The first pillar is the DDI pillar, that integrated, as I mentioned, DNS, DHCP, IPAM in a single instance, which can be a hardware, software, or a cloud instance. The second pillar is the DNS security pillar, and here we have a complete suite right from the basic device, which in itself is hardened. We have the instances available in cloud, and we have a unique offering called DNS Guardian, which handles 0-day or unknown DNS attack protection. I mean, if you have some time, we would like to talk offline on that. That's a big area that we do, and that's something that uniquely that we do from a DNS Guardian perspective. We have DNS on the cloud and DNS Blast, which is more of a telco platform. Thirdly, as I mentioned, we started off with an IPAM solution, IP address management, and that helps you on a single pane of glass as to what kind of IP inventory you are maintaining in an organization, right? But we also have an active network discovery to complement this particular tool, right, as a part of the complete solution. And this is something called as, we call it as net change or network discovery solution. So that's something that is another strong portfolio that we have. And lastly, third tower is basically GSLB, a global server load balancing solution specifically for the DNS. That's another, you can say, offering from a DNS perspective that we have. To see to it from an edge and a core perspective, the user is able to reach the application on services in the fastest possible manner. So right, with that kind of introduction, I'll hand it over to my colleague Chirag to deep dive into what we do from a DNS zero trust architecture perspective. Yeah, over to you.
Customer logos.
It's
All right. Yeah. Good afternoon, everyone. Thank you for joining for the session. As you know, we saw in our last session, zero trust is one. So what we see is zero trust, micro-segmentation is everywhere. And as we have cloud deployments going across different segments, different container-based solutions that are getting deployed, architectures are getting more and more complicated. And customers are, into a trouble of having IoT, having silos of, different container solutions and having cloud solutions. And how do we bridge data centers and different solutions at the same time with a zero trust architecture? And as you see in zero trust, these are the three key pillars that we talk are very important. First thing is visibility. How do I get a visibility of the entire environment, that how the applications are talking to an user? Real-time analytics of what's going on. East to west, south to north. I want complete visibility. Most of times we have a visibility from north to south, but we don't have visibility from east to west. That is missing. And that is where zero trust deployments becomes problem. They are not completely deployed. And third and most important part is automation. How do you orchestrate and automate different solutions together on a single pane of glass? Probably we are not doing the entire zero trust, just to clarify, but we do a very small part of zero trust from a DDI and DNS security perspectives. So let's try and understand how DNS would bring a security layer between user and application, and then I would move to zero trust architectures at what use cases that we can, help them solve to our customer architectures. DNS, as Ranjit mentioned, it's one of the critical application. It is a business critical application. Any user who is trying to access any kind of a content, intranet or internet content, he would be accessing over domain name. And for that domain name, the resolution happens over a DNS server. So that's where DNS becomes a bridge between user and application. In case the DNS is not available, the user is not able to access the application. So that's where if no DNS, no business. So that's where DNS is business critical. At the same time, it has to have a proper security infra in place. And kill chain cycle is not something new that we see. If we talk about HTTP, HTTPS, or any kind of cybersecurity attacks that we talk, kill chain is the first thing that we talk is the machine is infected by the malware. Then this machine is trying to talk to CNC or botnet server, and the data is getting exfiltrated outside. And DNS is also one of the protocol which is used to do a data exfiltration using DNS. So let's try and understand why DNS and what kind of environment that we talk about. If you see here, normal clients from the LAN environment perspective or server segments perspective are not allowed to access internet directly. Port 80, 443 or port 53 is blocked. But this client has an access to internal caching DNS server. And this caching DNS server has an access to internet over port 53. So let me explain about DNS tunneling, what DNS tunneling means, or data exfiltration, what DNS means. Many times we have a misconception or understanding that my firewall or my network side of solutions are taking care of DNS security. Definitely they do some part of it, but they are not purpose built to do full DNS security. And as this machine has an access to an internet, not directly, but through a proxy or through a DNS for resolution. Now this machine is infected by a malware, which would be trying to communicate with CNC server over different protocols. And DNS is also one of the protocol which it will try and see if I'm able to reach out to my CNC server. So this machine is exfiltrating the data using DNS. If you see here, this is an RFC standard DNS query which is going outside from this machine. If you do a packet capture, I will see a proper DNS packet that is going. And if you see here, the characteristics, safeplace.com is a common domain, but the characters in front of the safeplace.com is dynamically changing, which is known as DGA, dynamically generated algorithm, which is changing the algorithm. And this is making a DNS cache server to push all the queries outside. Which is, I do not have the entries in the cache, everything is pushed outside. And because of which, the CNC server is able to know this is a start packet, this is a last packet, and I have to build up a file. Technically speaking, if you see here, this is a genuine DNS packet that is going outside. Many times next-gen firewalls would claim we can inspect if somebody is sending HTTPS traffic within DNS. Yes, they can do it. But if it is a DNS packet that is going and this safeplace.com is a zero-day domain, how do we prevent it? That's why that solution is not purpose-built to do DNS security in a way. So coming to my point, the client never had access to internet, but through DNS he is able to now access and he is able to exfiltrate and try and do anything, everything which he wants to do. He has a complete access to internet on port 53. Because on DNS, what we say is source DNS, destination any, port 53 allow for resolution. So that's why this is a blanket that goes outside. And that's why DNS security is quite important to be covered up. So as we talk about DNS, DNS is one of the oldest protocol in the industry. The time internet was born, DNS was the first protocol that was born. It was lightweight, it was meant to be easier, and the communication quite easier. That's why it was on UDP. Any communication that happens from client to an application, as we discussed, opens our domain name. So you get more information from DNS that what is the user trying to access, what application, what resources, and what servers in my segment. So DNS becomes your first line of visibility. As it becomes your first line of visibility, it can also be your first line of defense, which we typically miss out. We always jump over HTTP, HTTPS, or the last mile of application, but somehow we miss out is the DNS can also bring a value to the visibility, and it can also bring a value to the security as the first 10. And again, when we talk about security, it can give you a lot of visibility about the client ID, destination domain where the client is connecting, what are characteristics of the client, what are the query type, fragmentation, what duration that the DNS queries were running through. Lot of information that you can get which probably is ignored or probably is not been monitored within the environment. And that's where DNS becomes a key component with an IT environment, any IT environment, as we talk about security aspects. So these are 4 steps, as sir mentioned about, the visibility, collecting the data, then analyzing it properly, and then taking countermeasure. And integrate with the SOC and SIM tools to ensure that the entire ecosystem of the network security is integrated on that side. So I'm not going very nitty-gritty of how do we, are preventing this kind of attacks. The idea here was to, bring up a point that DNS security is still one of the key aspects which is still open in many of the organizations, which needs to be seen. And now coming to client behavioral analysis from DNS perspective, that is also very important. DNS can give you a lot of metadata, a lot of visibility about how your east to west, south to northbound traffic is running in an environment. As I mentioned, mostly we all care about what's going outside. In zero trust architectures, we talk about east to west is a major. Because if one of the machine has access to internet, east to west he comes here and he goes outside from here. You still have a bridge which is going out. So you still have to have a security layers for east to west traffic that has to be prevented. And that's where DNS brings a lot of analysis for east to west traffic. It gives you a lot of behavioral analysis, how the users are behaving, and what kind of a domains they access. Any malicious machines that I'm talking to and internet, I get a real-time visibility about how the machines are behaving, and we can take a countermeasure. And that's where, as you see, IDC has clearly mentioned for zero trust architectures, behavior-based analytics is quite necessary. They are not specifically mentioned about DNS. It is holistically on the network, and DNS is also one of the protocol which needs to be deployed in same manner. So this was kind of a background. I thought I would set up from security and zero trust, that what it brings on from DNS application perspective. Let's try and understand how client query filtering or how access controls on DNS level can bring a value proposition. In a zero trust architectures, controlling which device has an access to which application, which domains and which services is quite critical. Most of the solutions are deployed with authentication. And this authentication would define based on apps and services. Probably domain name is missing over here if you see. Authentication does a very blanket part of it on a user level, but not on the application level that they are talking. Again, these policies that are put on firewalls or on different solutions are overall. They are not on individual level. That's where it becomes quite complicated to deploy it on firewalls or routers. If you have 10,000 employees, you cannot write 10,000 different rules for each employee. It becomes quite tedious to do it. And ground control in microsegmentation is quite key, which is again one of the key aspects that one has to look in. So that's where, as we talk about DNS security from a zero trust architecture perspective, visibility, which client should be allowed or denied to which domains is quite important. And third and most important part is putting the filters automated way. And that brings a lot of use cases, as you see, parental control, VIP access, or IoT devices. And what we are seeing, a lot of customers today deploying IoTs. Frankly speaking, IoT devices, you do not have no control. You have NAC solutions deployed, you have endpoint security solution deployed. Or on IoT, you cannot deploy these solutions. You cannot control. And what that IoT device is talking to, you cannot know. And that IoT device has an access to DNS and has access to your network. Probably restricted on network, but has access to a DNS server. That's where we see a lot of big use cases coming from IoT these days. And that's where we see client query filtering becomes quite important from zero trust architecture. So let's try and understand what is client query filtering. Client query filtering brings a value of, I have a set of clients, I have a set of list of domains that I'm seeing, these clients are allowed to access these domains. You can have multiple groups of clients, multiple groups of domains, and you can map them automatically. It can be statically managed or it can be done automatically. By doing this, we have multiple use cases that can bring a benefits. Can know visibility of individual clients. I know my LAN users should be allowed to access most of these domains, should be blacklisted with these domains. One use case. Second use case, based on DNS, I want to restrict IoT devices. IoT device should only be granted access for 5, 10, 15 domains, which it wants to access. Beyond that, restrict. By default, the IoT device has access to a DNS as a full. And DNS server has access to internet. So by default, you do not know what traffic is going from the IoT device from a DNS perspective. So that's why I have two use cases, just to, there are multiple use cases, but just to cover from zero trust architecture, how DNS can be a, important tool from controlling the attack. So first use case is the user access apps and services via denial list. So via client query filtering, I have a list of clients and domains that are mapped. I have a default client which has access to internet. I have no problems of restrict access. I have identified clients which are sitting in different environments. I want to give them access to a restricted domains. So I want to blacklist few of the domains that they're accessing, few domains I want to allow. The client matches the domain list, he is allowed. Any domain that client matches a block list, that is blocked within the DNS level. Probably we are doing this on proxy, on HTTP, HTTPS level. What we are doing here is on a DNS level. So if I'm ensuring that which source is allowed to access what kind of applications on intranet or on internet. These are again very important aspects to control any kind of east to west or south to northbound traffic. Second use case is very interesting, IoT, and we are seeing many customers, are talking about this as a pain area. Again, I have a default laptop which has an access controls and it is able to access the intranet or internet applications. Now I have different IoT devices, and these IoT devices, when they connect, they ask for an IP address from a DHCP server. And this DHCP server would allocate an IP address and allocate a DNS server IP address. Once this IP IoT device is connected, from a framework perspective, as we are a DDI vendor, the DHCP lease information will get updated on IPAM, and IPAM will orchestrate the information to DNS, please update the client list. So everything that you see over here is happening automatically. There is no manual intervention. Once the list is updated as the IoT device is connected, this IoT device has the restrictions for only allowed for specific domains. Rest domains are blocked. The first use case that we had was, I'm allowing most of the domains, I'm restricting few of the domains to be allowed. In this use case, I'm just saying IoT is allowed for 10, 15 domains, rest all is restricted. So as you see here, when IoT device tries to connect, the domain which is whitelisted over here, he is allowed to go outside. When the IoT device is trying to connect any of the domain which is not within the allowed list, he is denied the connection. Technically speaking, you can put access controls over IP addresses, but DNS access controls are not really deployed. That is where we play an important role of controlling this micro-segmentation or zero trust architectures. The key 3 takeaways that we would like to again highlight as a conclusion. DNS virtually sees entire traffic, let it be east to west or south to northbound traffic, because every query that goes as a HTTP, HTTPS, or probably SNTP or SNMP traffic, it is over a domain name. And DNS will definitely give you a lot of visibility. Client query filtering helps you to put a lot of access controls, probably that can avoid a lot of micro-segmentation problems which today you are facing. And third and least, but very important part is with 2 different mechanisms. One is we have threat intelligence feeds coming in. We know these are the bad domains. We are restricting the access. Second is based on our behavior-based analysis. We try to analyze the traffic and countermeasure on a real-time basis, which ensures the zero trust architectures are very well taken care. And these are the key benefits. We spoke briefly about all of them, which ensures a lot of different use cases which today's customers are trying to deploy in their environments. And secondly, they can very much ensure that on a DNS level, they definitely put access control. I'm sure zero trust is very broad environment that we talk about, and we play a very important role and a very niche part from a DNS protocol, but which is very important to be considered in. So that's all from my side. Yeah, thank you. If there are any questions, I'm happy to, Thank you.
Great, thank you so much. Do we have any questions? Yes, sir.
I'm Biplab from 𝗘𝗱𝗃𝗃. We have a large number of IoT devices,
Right.
and we were earlier controlling the traffic through firewalls.
Right.
But our group policy is very hardware minded. So we had total OT network and IT network we have separated.
Correct, sir.
So in that case, will your solution will be of any help to us? Because
Absolutely.
my manufacturing network is not connecting to internet. And
Okay.
even if it is connecting for disaster recovery purpose, we are keeping data in a remote site in AWS. That is the only connection. For that purpose, we have separated the OT.
Correct. So, sir, what we are seeing is definitely you have put one very good thing is you're not allowing your IoT devices to talk to internet, which is good, or probably to talk to the other infra. If you're physically segregating, which is okay. Most of the time what we see IP cams, most of the different electronic devices that are getting connected, probably they are still part of the same IT environment. Different VLANs, probably through a routing or somewhere, they are still able to access because they need to replicate the data somewhere. And they have an access to DNS. Probably what we think is, what will DNS do? Resolution. But as I explained about DNS tunneling, if the machine is compromised, the IoT device is compromised, it can exploit the data. Probably this IoT device doesn't have access to internet, but it has access to a different machine. And this machine has access to internet. Probably somehow if it is able to communicate, the packet might reach out to internet that way.
No, we have made it, make sure that there is a total separation between the IT corporate network
Correct.
and the OT network,
Right.
using the air gap policies and etc.
If it is fully isolated, I would say then zero trust doesn't bring much value out there because it's already isolated. And there is not much of things that is shared outside the network. But when we talk about zero trust architecture, we are sitting next to each other. Probably we access different content, I want to restrict the access. That's where the zero trust comes in. And where IoT device is also sitting in the same network. Probably it can be a router, or probably it can be, probably I would say IP cam, which is a very classic example that I've seen many organizations. Or any kind of electronic device that are getting added. IPTV, most of times when we go to conference rooms, we have TVs which are connected to IP addresses, right? So these are all IoT devices, and you cannot put endpoint security over that machines. How do you control? And they all have access to DNS. But they have to connect to a corporate network. Probably you want to do some presentation remotely, you still have access to that, TV or some other machines. So that's where DNS also can play a very important role of, restricting access, which is missed out.
Thank you.
Great. Thank you so much.